The dreaded motion problems have returned. And so I'm going to be doing problems 19, 20, and 22, I think. I'll go ahead and read the problem off. I don't want to write the problem down. 19 reads, the hiking club went on a hike one Saturday in the morning. They walked an average speed of 3 miles an hour. So whenever I get a number, and I know that's a rate, right? So I'm going to put it as an R. 3 miles per hour. I'm going to write down whatever rate, whatever distance they give me. And this is in the morning, so I guess I'll put M for morning. All right, in the afternoon, they averaged 2 miles an hour for 1 more hour. Okay, so here's A for afternoon. And the rate in the afternoon was a little bit slower. I guess they're getting tired, so they're only going 2 miles per hour. And they walked in the afternoon for 1 extra hour. So whatever their time was here in the morning, we don't know what that time is, but whatever that time is, they added an hour to it in the afternoon. All right, so again, at this point, I'm just writing down information. I'm not really doing any calculating yet. And then I'm asked how many hours did they walk in the morning if they walked a total of 22 miles per hour. So here's the distance for both of them. It's going to apply to both of them. The distance is going to be 22 miles. Did I say miles per hour the first time? It's just 22 miles. It's a distance formula. Yeah, distance is in miles. Okay, so for the purposes of this problem, what we want to do is we know the total distance is 22 miles an hour. I keep doing that. We know the total distance is 20 miles. So we just want to add these two things together. Add their morning to their afternoon and make that equal to 22 miles. Remember, the famous formula that we're dealing with here is distance equals rate times time. Okay, so total distance, 22 miles. Okay, and that equals whatever they walked in the morning, so that's rate times time in the morning. So they had 3 times t, whatever that time was. And then in the afternoon, we're going to add to that 2 miles an hour times t plus 1, because remember, in the afternoon, they're walking for that extra hour. Now, what's really interesting here is if you look at this equation here that we ended up with, it's really not that difficult to solve at all. Like, the hardest part of this problem is just the setup. But if you get the setup, like, the actual algebra isn't too bad, right? You distribute that 2, and what you'd end up with is 3t plus 2t plus 2. Now we can combine our like terms. We can subtract. I'm going to go a little bit faster here, right? If I subtract 2 off of 22, I will have 20. And then I'll have 5t if I combine these guys. And so t equals 4. And that is going to be the amount of time they were walking in the morning. The total time would be, 4 plus the 5 hours they walked in the afternoon. And that would be a total of 9 hours. But the question was just asking, how many hours did they go walking in the morning? And that's, okay, they spent 4 of those hours doing the morning hike. All right. Hopefully it wasn't too confusing. Number 20. This one you have Bob. So I'm going to put a B for Bob. And they're telling us that Bob left Centerville at 11 a.m. So I don't actually know what the time is. I'll just put T with the question mark. I just know it's 11 a.m. But I don't know how long. And he travels west for at a rate of 45 miles an hour. So there is Bob's rate. That's how fast he's going. Lane leaves Centerville, same place, but at a different time, at 1 p.m. So here's Lane. His time, we'll get to in a little bit, but for right now, like, we don't know the time, we just know, when he left. And his rate is going to be 50 miles per hour. And the question is going to be, at what time will they be 375 miles apart? So again, in this problem, we know what the total distance is. The total distance, even though, they're walking in opposite directions, right? Bob's going one way, Lane's going the other way. They started in the same point, but at the end, they're 375 miles apart. So we know what that is. That's 375. That's the distance. We've got that one locked in. We know the rates. All we have to worry about is the time. Now, here's what the question said, and so it's good to think about this. Bob leaves at 11 a.m. So let's think about this. Suppose that Lane, he leaves at 1 a.m. and is it p.m.? Am I saying a.m.? No, 1 p.m., sorry. Lane leaves at 1 p.m., Bob leaves at 11 a.m. Let's say that Lane leaves at 1 p.m. and he walks for an hour. So in that case, I'm just going to do a little side over here. In that case, Lane will have walked for 1 hour, right? Because he started at 1 p.m. Well, think about this. How long had Bob been going at that point? Well, he started at 11 a.m., right? So that's 2 hours earlier. So when Lane has walked for 1 hour, Bob has actually gone for 3, right? And you can do the same thing. Like, let's suppose, that Lane goes 2 hours. If Lane is going 2 hours, Bob will have walked 5 hours. 4 hours. I can't do arithmetic. I'm making this problem a lot harder than it needs to be. But you see the pattern. You see the pattern here. Every time Lane goes for an hour, or whatever time, Bob will have gone 2 hours more, right? It's always going to be plus 2. Bob will always have gone for 2 hours longer than Lane, no matter what Lane's time is. Sorry, I probably made that a lot more confusing than it needed to be. But now we have enough information to make our formula here. So we got 375 miles equals rate times time. So we got 45 times t plus 2. All right. And then we're going to add that to Lane's, which is 50 times t. Again, once we get to the actual equation, once you get the equation down, the math is not too bad. We're going to distribute and simplify. So 375 is going to be equal to 90 t. Sorry. Oh my goodness, I am messing up all over the place today. This is a sloppy video. 45t plus 90. Forgive me. Plus 50t. Okay, we're going to go ahead and subtract the 90 from both sides, so that'll give us 285. And then 45 and 50 will be 95t. And if you divide 285 by 95, you will actually get the number 3. Now, we're not quite done yet. So remember, this is how long Lane has walked. He's walked for 3 hours, right? Because we solved for t, not t plus 2. We solve for t. He's been walking for 3 hours. But the question actually says, at what time will they be 375 miles apart? So I have to remember, when did Lane leave? He left at 1 p.m. So what's 3 hours after 1 p.m.? And the answer is 4 p.m. So at that time, these two guys will be 375 miles apart. All right. Last one I'm going to do. 22. I'll have my camera here. Okay. So here's 22. Mrs. Vaughn and her son live 184 miles apart. So I'm just going to write that down. 184. They gave me the distance again. If they leave their house at the same time and head towards each other, they will meet in 2 hours. So there's a time. They'll meet in 2 hours. All right. Martin travels 12 miles per hour faster than his mother. So I have Martin and mother. That's M and M. So we'll put Martin. I'll spell his name Martin. And mom. And we know whatever mom's rate is, Martin's is going to be that plus 12. All right, so let's figure out how fast they're going. This is going to be very similar, except this time we actually have the time, but we don't know are the rates. But we can find them by just plugging it into the distance, 184, equals rate times time. So this will be r plus 12 times the time. Sorry. Oh my goodness. I was hoping I could do one problem without messing it up, and I didn't. We know the time is 2, so I'll put that in there. Plus 2r for his mom. And I probably should have put the 2 out in front. I was going rate times time, but you could do time times rate as well. Anyway, if that confuses you, just rewrite it as 2 times r plus 12, because you're going to be doing the same kind of thing. You're going to be distributing, right? So I distribute the 2 into this, and what I'll get is 184 equals 2r plus 24 plus 2r. Okay, subtract 24 from both sides, and I'll get 160 equals 2r plus 2r. That's 4r. So r is going to be 40 miles per hour. And whose rate is that? Well, that's Mom's. Hers is the one that's just the r. And that means Martin's rate is going to be 12 plus that. So that's Mom. And then Martin's is going to be 52 miles per hour, because that's 40 plus 12. 40 plus 12 is 52. There's Martin.